What happens if software fails in an aircraft? Unlike in automotive systems, there is no safe fallback, no way to simply stop the system. Aircraft systems must operate reliably, under all conditions. A software failure can have immediate and critical consequences. This is why software in aviation must meet extremely strict requirements. And one of the most important standards for this is DO-178C. It defines how software must be developed, verified, and documented to ensure it is safe for use in aircraft. In this video, we explain what DO-178C is, how it works, and why it is essential in aviation. Why does DO-178C matter? Aircraft systems operate in highly critical environments. Unlike many other domains, there is no simple fallback. You cannot just stop the system or restart it safely. If software fails in an aircraft, the consequences can be immediate and severe. This is why aviation requires an extremely high level of reliability. Software must behave correctly, under all conditions. And to ensure this, strict certification processes are required. DO-178C defines how this certification is achieved, and how software must be developed to meet these expectations. So what is DO-178C? DO-178C is a guideline for the development of airborne software. It is used to ensure that software is safe for use in aircraft systems. The standard defines how software must be developed, verified, and documented. It focuses on structured processes, rigorous verification, and clear evidence. The goal is to demonstrate that the software behaves correctly, under all expected conditions. DO-178C is widely recognized by aviation authorities worldwide, and it plays a key role in the certification of aircraft systems. A key concept in DO-178C is software levels. These levels define how critical a software function is. They are based on the potential impact of a failure. Level A is the most critical. A failure at this level could lead to catastrophic consequences. Level B and C represent decreasing levels of severity, but are still highly relevant. At the lower end, level D and E represent minor or no impact. These levels are important because they determine how rigorous the development and verification must be. The higher the level, the stricter the requirements. So how is software developed under DO-178C? The development process follows a structured life cycle. It starts with requirements, where the expected behavior is defined. Then comes the design phase, where the system architecture is developed. After that, the software is implemented. And finally, it must be thoroughly verified. But what makes DO-178C special is the level of rigor. Every step must be clearly documented, and all artifacts must be traceable. This means that requirements, design, implementation, and verification are all connected. This traceability is essential for certification. Verification and validation play a central role in DO-178C. The goal is to ensure that the software meets all requirements. This is not limited to testing. Verification includes multiple activities, such as reviews, analysis, and testing. Each development step must be verified. Requirements are reviewed, design is analyzed, and code is tested. Another important aspect is independence. For higher criticality levels, verification must be performed by independent teams, and all results must be documented. This creates the evidence required for certification. So verification is not just a final step, it is an integral part of the entire development process. So how does DO-178C compare to ISO 26262? The first difference is the domain. DO-178C is used in aviation. ISO 26262 is used in automotive systems. The focus is also different. DO-178C is centered around software certification. It requires clear evidence that the software behaves correctly. ISO 26262, on the other hand, focuses on the functional safety lifecycle. Another key difference is the approach. DO-178C is strongly evidence-based. ISO 26262 is more process-oriented. But both standards share the same goal: ensuring safe system behavior. What challenges arise in practice? One of the biggest challenges is the amount of documentation required. Every step, every decision, must be clearly recorded. Verification is also very demanding. For higher criticality levels, independent verification is required, which adds complexity. Traceability is another key challenge. All artifacts must be connected, from requirements to implementation to verification. There is also close interaction with certification authorities. And finally, projects must balance time, cost, and rigor. Meeting all DO-178C objectives requires significant effort. There are several common misunderstandings about DO-178C. One of the most common is the belief that testing alone is sufficient. But verification includes much more, such as reviews and analysis. Another misconception is that documentation is just a formality. In reality, documentation is essential for certification. Some also believe that DO-178C is only relevant for large projects, but it applies to a wide range of aviation systems. And finally, it is often compared directly to automotive standards. While there are similarities, the approach is fundamentally different. Let's summarize the key points. DO-178C defines how software must be developed for use in aircraft systems. It introduces software levels, which determine the required rigor. It places a strong emphasis on verification and evidence. The development process must be structured and fully traceable. All of this is required to demonstrate that the software behaves correctly. And ultimately, DO-178C is essential for ensuring safety in aviation systems. If you want to go beyond this introduction to DO-178C, we offer comprehensive online training programs on our website. These courses cover aerospace software standards, as well as automotive and cybersecurity topics. The focus is not only on understanding the concepts, but on applying them in real engineering projects. You can find the link in the video description and also in the pinned comment below. If you found this video helpful, feel free to give it a like and subscribe to the channel. We regularly publish content on functional safety, cybersecurity, and aerospace standards. Thank you for watching, and we look forward to seeing you in the next video.